All right, today we're going to talk about logarithms. Now, this conversation is not going to start with some long, drawn-out, me trying to explain to you what a logarithm is. We're not doing that today. We will do that, but not today. Today, we are simply going to practice using logarithms and evaluating logarithmic expressions. So, we are going to have a list of properties, and we're going to build the list as we go. Problem number one, we're going to do this whole page, and we're going to do this whole page without a calculator. We can do it. There is a property that I want you to know that says the log base b of b to the x is x. Now, when you look at that, it looks so scary. But when you look at this problem, log base 5 of 5 to the first power, there's like an understood exponent there. Would you agree with that? The answer is the log base 5 of 5 to the first, the answer would be 1. That's it. No. Look at your property. Look at your property. And it says, when these two numbers match, the answer is the exponent. So these two numbers matched. So the answer was the exponent. Now, listen, I don't expect you to have crystal clear clarity at this moment. We're just starting. But you do have to write that down, and you have to know that. So that when you run into the log base 7 of 7 squared, you will just say immediately the answer is 2. Okay? Now, don't get tricked. The log base 6 of 2 to the 6th is not 2. The property only works if these two numbers match. Got it? So we can't do that one. But as long as these two match, the answer is the exponent. Now I want you to look at the next one. It says the log base 4 of 16. Now wait a minute, kids. Wait a minute. What do you know about 16? It's 4 squared. So isn't this the log base 4 of 4 squared? Isn't that what this is? Isn't 16 4 squared? And what does our property say about the log base 4 of 4 squared? It's 2. Now I'm going to skip number 3 for a minute. I promise I'll come back. I'm going to skip it for a minute. I'm going to go to 4. Now, what appears to be missing in problem 4? There does not appear to be a base in there, does there? Okay, next thing to add to our list of stuff to know. The symbol LOG always stands for log base 10. These are called common logarithms. When you see an LOG and there is no base on it, you are to put in a 10. There is an understood 10. Now, tell me about 1,000. It's not 100 squared, it's 10 cubed. It's 10 times 10 times 10. So this is the log base 10 of 10 cubed. What is the log base 10 of 10 cubed? 3. Our property says that when these two numbers match, that's the answer. Number 5. Okay, now wait a second. This is where we really got to start paying attention. My Brownlow, you paying attention? Okay. Now, in order to do this without a calculator, we really need these two numbers to match, don't we? So I've got a 4 and I've got a 1/16. Now, is there at least some hope of getting the same number? Because what do I know about 16? It's 4 squared. So this is the log base 4 of 1 over 4 squared. Now, 1 over 4 squared is not good enough. But 1 over means what kind of exponent? Negative. This is the same as the log base 4 of 4 to the negative second. Because 4 to the negative second means 1 over, doesn't it? We're doing it backwards now of how we did it before. Before, we started with the negative exponent and got the fraction. Now, I'm asking you to remember that 1 over always means a negative exponent. I'll say it again. 1 over always means a negative exponent. So 4 to the negative second is 1 over 16. What's the answer to this question? Negative 2. Negative 2. Skip number 6, we're going to 7. Now wait, I have a radical. What does a radical mean in terms of exponents? It means a fractional exponent. So, Bryce, the cube root would be what fraction?
1/3.
You are exactly right. So this is the log base 6 of 6 to the 1/3. 6 to the 1/3 means the cube root, doesn't it? These are interchangeable. These are the same thing. So if I write the radical as an exponent, then I have the log base 6 of 6 to the 1/3, and the answer is 1/3. Number 9. I know I'm skipping some. I'm going to come back and get them, I promise. Number 9. Tell me about that.
7 squared.
That's the log base 7 of 7 squared. Isn't 49 7 squared? So the answer is 2. Number 10. Now this is another one of those crazy ones that doesn't have a base. There's no base here.
10.
But it's 10, so I'm going to go ahead and write 10 there. Now this is not good enough. That has to be a 10. It cannot be a 1/10. So what do we know about 1 over? What kind of exponent does 1 over mean? Negative. So this is the same as the log base 10 of 10 to the negative first. 1/10 means 10 to the negative first. What's the answer? Negative 1. Number 11, log base 3 of 1/9. Tell me about 1/9.
You have to make it a negative.
You have to make it a negative exponent, don't you? What exponent do I want? I really want that to be a 3. That'd be the log base 3 of what? 3 to the negative second. Because what's 9? 3 squared. But it's 1 over, so it has to be negative. So what's the answer? Negative 2. Hopefully you're starting to get the hang of it. Look at number 12. I heard somebody give me the answer already.
It was Abby.
Abby knew the answer already. Because Abby knew that there's a base 10 on that. And 100 is 10 squared. Right, Kaylin? So the answer is, Abby, you are exactly right, 2. How about number 13, log base 6 of 6? What's that?
1.
That's 1 because this is 6 to the first. That's 1. Uh-oh. Look at number 14. Now stop a minute. Radicals are what kind of exponents? Fractions. So this is going to be a fractional exponent. What fraction is a square root?
1 over 49.
Half?
2 over
1 over 2. Square root is a 1/2 exponent. Doesn't this tell me to take the square root?
Yeah.
So what's the answer? 1/2. Okay, all right, so now we got to talk about something new. All right, I'm going to add another property to your list. The log base b of 1 is always 0. When you take the logarithm of 1, I don't care what the base is, you're going to get 0. So when I look at problem number 8, it says the log base 4 of 1.
0.
The log base 4 of 1 is 0. When I look at problem 28, it says the log base 8 of 1, that is 0. I don't care what your base is, kids. If you are logging 1, your answer will be 0 every time. The log of 1 will always be 0. You'll understand that better on Monday. But for now, that's a property you just have to know. Okay? Now, I want you to look at problems 18, 19, 23, 24, 25, and 27. Okay, so let's look at those. We're looking at 18, 19, what did I say? 22, actually, we can look at. 23, 24, 25, and 27. Now, let's look at this one right here. This was number 18. This actually is another property. Does anybody just want to take a wild guess what the answer is? 10. You're exactly right. There's a property that says, I'll add it up here, b to the log base b of x power is x. So remember how the first property we talked about, we said if these two numbers match, it's x? Well, if these two numbers match, it's x. So take a look here. See how these two numbers match? These are the two that have to match. So look at this one. Do the right numbers match? So the answer is 2. Wait on that one for a minute. Look up here.
11.
Do these match? 11. 7. Uh-oh. What's missing?
An X can be
The base.
or the
But
base.
remember, this is an LOG. And what do we know the base is on an LOG? 10. Now they match, so the answer is 7. Yes, it is a trick question, but you're supposed to know LOG means base 10. Now, we have to talk about this guy. What does LN mean? LOG means log base 10. Does anybody remember from algebra last year it stands for, it is a natural logarithm, that's exactly right, it's a natural log, not a common log, a natural log. What does that symbol stand for? Log base E. Log base E. Now, do you know how in geometry you have a number that's used so much, it has its own letter, it's called pi?
Yeah.
And you know pi stands for a decimal, 3.14159. But we use it all the time, so instead of writing 3.14 all the time, we just write the symbol pi.
Yeah.
This is the same thing. This number is about 2.718. It is used all the time, so instead of writing the number over and over and over again, we use the symbol E. When you see ln, that means log base E. So when I look at this problem, which is number 22, this is number 22, that symbol means log base E of 4. This symbol means log base E. So what is E to the log base E of 4? 4. Remember, when these two match, it's the other number. How about this one?
6.
This means E to the log base E of 6, which is 6. That, right there, was number 27. Now I'm able to go back and fill in some of the ones I didn't do. Look at number 3. It says ln E cubed. But if that's log base E, what is the log base E of E cubed? 3. That's problem 3, and the answer is 3.
What was 1, 2, 3?
Look at number 6. Now, come on, there's a lot going on here. Do you see 1 over?
Yeah.
What does that mean?
Negative.
Negative exponent. So this is ln E to the negative third. What's ln stand for?
Natural
Log base E. So what is the log base E of E to the negative third?
Negative 3.
Negative 3, that's your property. Right? When these two numbers match, Katie, it's this number. So that's number 6. What's the next one I skipped?
8. No.
I did 8. 15. We're up to 15 now. Anybody want to tell me what the answer to 15 is?
10.
It's 10. This is the log base E of E to the 10. That is 10. How about 16? Oh, Lord. We have a radical. What does a cube root stand for in terms of exponents? 1/3. So we have ln E to the 1/3. What's the answer? That's log base E of E to the 1/3. That's 1/3. Now, you may not need to write all these steps down. Do not feel you have to write all these steps down. If you can look at it and tell me the answer, that's okay. 17. 17 is 1 over E. Now, what does 1 over always mean?
Negative.
Negative exponent. So this will be ln E to the negative first.
Negative 1.
And the answer is negative 1 because this means log base E of E to the negative first. Okay. There's only 1 left, or 2 left. No, 1. 26 is the only one left.
21.
There's 20, 21, 26.
Oh, okay, so 20, 21, 26. Okay, let's look at 20. Okay, let's look at 20. Now, I want you to forget this 2 for a minute and pretend that's your problem. So that would be the log base 3 of 3 squared, wouldn't it? And what is the log base 3 of 3 squared? 2. So this part of it, right here with the circle around it, that part equals 2. Now what do I need to do with that 2? Times it by 2, so the answer is 4. All right, let's look at 28. Or not 28, 21. 21 says 3 log base 2 of 8. All right, cover up the 3 for a minute. What's the log base 2 of 8? That would be the log base 2 of 2 cubed, which is 3. So that's 3. But what am I doing with that 3? Multiplying it by 3, so the answer is 9. And finally, 26. 4 log base 2 of 2. All right, let's do this part. What's right here? Log base 2 of 2. That is 1, you guys. Remember, this is 2 to the first. So what's the answer to the question? No. This is 1, but you got to times it by 4, so the answer is 4. Whew.
Oh boy.
That was a lot. Tonight for homework. Look, if you would, if you have your book, that would be super. You need it for tonight. I don't care about today's dinner. When you look at page 308, which is where your homework is, I've assigned 24 problems, and they're all just like that review sheet. So you should do them all without a calculator. Remember, any radical you see is a fractional exponent, and any 1 over you see is a negative exponent. Remember that your essays are due Monday.
So is it
Our
Our essay is about us, right? About